Hello student, welcome to chemistry class. In today chemistry class we will revise again P block element with the help of board question and some competitive questions. Okay. Uh, this time we are choosing some different questions. Okay. First of all we will see MCQ, then in next class we will see the assertion region, then case study. Okay, let's start. Our first question is on addition of concentrated. First question is on addition of concentrated H2SO4 to a chloride, SO4 to a chloride, salt, chloride salt, colorless fume are evolved. Colorless fumes are evolved. Colorless fumes are evolved. But in case of iodide salt, violet fume is violet fume come out. Violet fume come out. This is because first option is H2SO4 reduced to Hi to I2, and second Hi is of violet color, and third one is Hi get oxidized to I2, and fourth one is Hi change into HiO3, hydroiodic acid. Okay, what is the question? On addition of concentrated H2SO4 to chloride salt, colorless gas is evolved. Okay, but in case of iodide salt, violet fume come out. This is because why? First option is saying H2SO4 reduced to Hi to reduced Hi to I2. This option is wrong because either here oxidation is going on. This minus Hi is oxidized into I2, but here is saying reduced. Okay, so this option is wrong. Hi is of violet color. This is wrong also. Hi is not of violet color, but Hi get oxidized to I2. This is the correct answer because iodine is of violet color. Okay, then this option is also wrong. Hi change into the HiO3. Okay, therefore your right answer is Hi get oxidized to what? I2. Note down. Now we will see the next question. You can see or you can note by pausing the video. Now see next question. Which of following question is that which of the following elements can be involved in p-pi bonding. p-pi bonding. A is the p-pi d-pi bonding. Question here is d-pi bonding. Oxygen. Second one nitrogen. And third one is phosphorus. And last one is boron. This one is the C and this one is the D, boron. Okay, very simple and very clear question. Which of the following elements can be involved in p-pi d-pi bonding? P-pi d-pi bonding. Only those elements can involve in such type bonding which have vacant d orbital. Only those elements can involve in such type of bonding which have vacant d orbital. And as you know that in p block, first member of each family, whether that is from the nitrogen family, that is from the oxygen family or boron family, carbon family, halogen family, first element of each family has no d orbital, so they cannot form p-pi d-pi bonding. Okay, now you can see here oxygen has no d orbital, as you know that. Nitrogen has also no d orbital and boron has also no d orbital. Therefore this option is wrong, this option is wrong and this option is wrong. Then what will be right answer? You can imagine yourself. Okay, this is the phosphorus. Note down. Now we will see next question. Our next question is that which of the following pair of ions, question is which one of the following pair of ions are isoelectronic and isostructural. Ions are isoelectronic and isostructural. Isostructural. Okay. Now see option A. What is option A? Option A is the CO3 2 minus NO3 1 minus. Option B, ClO3 minus CO3 2 minus. And option C, SO3 2 minus and NO3 1 minus. And last is the ClO3 minus and SO3 2 minus. Student, in this question it is asked that which of the following pair in ions are isoelectronic and isostructural. Which of the following pair, which ions is isoelectronic and isostructural? Means structure should be same and number of electron or electronic configuration should be same. Now you see which one will be. Okay. See, in this case number of electrons are different in both cases. Here is 7 and 18. 7 and 18. 7 and 24 is equal to 31. And in case of this, here is 6 plus 24. Here is one more ion. Here will be 32, and plus 2 minus ion. Here will be 2 and 32. Number of electrons in both are same, but structure is not same. Similarly, in case of this, you can see here is the 7 plus 24 plus 1. Here is 16 plus 24 plus 2. Thus you can see that in this case number of electrons same but structure is different. In this case number of electron is also different. So these two options are wrong. In this case you can see here is carbon 6 and 24, 6 and 24, 30 into 32. Here is 7 and 24. It will be 7 and 24 is equal to 31 and 2. Number of electron is same, but structure is not same. Okay, so this option is wrong. This option will be right. Okay. Now we will see next question. What is the next question? These are the very important questions. Next question is affinity of hydrogen. Question is that affinity of hydrogen decreases in group from fluorine to iodine. Okay, which of the following halogen acid should have highest bond dissociation enthalpy. Highest bond dissociation enthalpy. Okay, highest bond dissociation enthalpy. Question mark. First option is HF, second HCl, third HBr, and fourth is HI. Student, here is question. Affinity of hydrogen means attraction toward hydrogen decreases in group from F to I, means fluorine to iodine. Okay, which of the following halogen acid should have highest bond dissociation enthalpy? As here is very clear, affinity decreases. In case of HI, here is affinity very less, so bond dissociation enthalpy will be very less according to size of iodine and according to affinity. So this option is wrong. Here is lowest bond dissociation enthalpy. Bond dissociation enthalpy. Okay, lowest bond dissociation enthalpy. Similarly, in case of this and in case of this. So here in this case, highest bond dissociation enthalpy. Okay, highest bond dissociation enthalpy. Okay, because hydrogen affinity is directly proportional to bond dissociation enthalpy. And this is also proportional to 1 upon atomic size of halogen Okay, this is the equation. Note down, as here is written, on moving from fluorine to iodine, hydrogen affinity decreases. So here is affinity very less and here is affinity very high. You can write here also one thing more, proportional to, I will write above, leave it 2 or more. Hydrogen affinity directly proportional to bond dissociation enthalpy, directly proportional to 1 upon atomic size. Now see the next question. Our next question is bond dissociation enthalpy. Same question but in the different way. Bond dissociation enthalpy of bond dissociation enthalpy of EH is the element. Okay, EH bond is given below. Okay, which of the compound will act as a strong reducing agent. Strongest reducing agent. Okay, bond dissociation enthalpy of EH bond is given below. Now see here is the compound. First of all, the compound, and next one is the bond dissociation enthalpy EH. Our compound is NH3 PS3, AS, S3, SB, S3 and BI, S3. These are the compounds. Okay, these are the compounds. Now, and their bond dissociation enthalpies are 389, and this is in the kilojoule per mole. This is the unit, and it is 3322, then 297, then one is not here, then 255. First option is NS3, second is PS3, third is ASS3, and last one is the SBS3. Okay. The strongest reducing agent. Okay. You see that relation is reducing power directly proportional to size of atom and directly proportional to 1 upon